Exercise 22 is combining the idea of functions now with the new data structure, tuples. All right, so tuples, if you recall from the lecture, um, is a list or a sequence of objects that can be essentially of any type. Now, in this particular program, we'll use a tuple that consists of floats as a return value from a function. And what's really useful about that is that we've learned previously that functions can only return one answer. And tuples are a really nice way of getting around that, especially when the multiple answers that a function might create are really um, sort of meaning the same thing, or they're closely related. All right, so what are we doing? We're going to be creating a function called find roots. If you know about a polynomial of of the form ax squared plus bx plus c, a, b, and c are constants. They're constant float values. X squared b and the x in the middle term is a variable. So a polynomial has roots, and a root is just whatever x value, and often there are two, an x value such that if you plug that in, the equation ax squared plus bx plus c will equal 0. And so it's kind of a common math program or a problem. So you can find these roots. You can find the x's that satisfy the equation using the quadratic formula, which I'm sure that you've seen in grade school or high school. And so the quadratic formula, and remember that this is actually two equations because you've got a plus and a minus. So you get two roots out of this, negative b plus the square root of b squared minus 4ac all over 2a, and another root where you got negative b minus the square root over 2a. This b squared minus 4ac is called the discriminant, and it could be negative. There's no reason to believe you're not going to get a polynomial where b squared is actually less than 4 times a times c. As you know, hopefully, computing square roots of negative values is particularly problematic. We'll need to calculate the square root of -1, which is an imaginary number. So for this, the computer does not deal with imaginary numbers very well. That's a whole other subject. So we're not going to consider any situation where the square root is negative as to have a root. All right. So your function is going to return a tuple representing all of the roots, and in some circumstances it'll return an empty tuple, something that does not have anything. In that case, when the discriminant is negative. In other situations, notably the situation where b squared is actually exactly equal to 4ac, there's only one root because negative b plus 0 over 2a is the same as negative b minus 0 over 2a. So your function is going to return possibly 0 roots, maybe 1 root, and then 2 roots in a situation where this value under the discriminant is positive. And I've given you some test cases. And these are important. We're going to kind of bake these in. I'm just going to print out the answer right now rather than going through and comparing it. And the reason I'm not going to compare it with an automated test is because decimal precision makes it a little bit more tricky. It's certainly possible to do. All right, so let me just actually copy this so we can bring this into our code. And let's start writing our find roots function, and it's going to take a, b, and c. Right now I'll return an empty tuple. In my regular program, I'm going to print out the result of find roots with the inputs that I've specified. So 1, 5, and 6. I'll do 390, 6. I'll do 2, 4, and 2. and 5, 5, and 6. And I'll just put some comments here. And again, this is sort of just scaffolding so we can write our program. Later on, we can morph this into something where the user might type in A, B, and C, and I can print out the roots. But it's nice to have baked in inputs so we can run the program frequently and not keep typing a bunch of numbers in. Okay, so just to start, certainly they're all empty, that makes sense. Now we'll actually start to take a look at doing this roots. So the key to knowing how many roots are going to be returned is understanding or knowing the value of the discriminant. So the discriminant is, again, b squared minus 4ac. So the first thing I'm going to do is just compute that. So b squared minus 4 times a times c. If that's negative, we will return an empty tuple. Okay, and in fact, if I just return, well, I'll keep it that way. And otherwise, D could be either positive, in which we would have multiple roots, or it could be 0. All right, so let's deal with the case that it's 0. And so if it's 0, if we look at that formula, if this portion is completely 0, then the answer, the one root, is just negative b over 2a. But now we're going to return a tuple, remember. The return value of find roots is a tuple no matter what. It's either going to be an empty tuple, a tuple with one element, or a tuple with two elements. So we've got the negative b divided by 2 times a. Remember that the literal representation of a tuple, if I just kept this would just be a number. This is not a tuple. And it's because the parentheses would be assumed to just be sort of superfluous. To make this a true tuple, I need to have a trailing comma. All right, that's a really kind of tricky little bug there. Now Python can return anything, so let's just return the word 2 roots. And I'm just printing it out, so it's okay. Okay, so I get 2 roots for the first 2 examples. We haven't dealt with that code just yet, but we see that that's certainly detecting it right, at least. We see that we should have only a single root here, and it looks like negative 1.0 is being returned. That's good. Negative 1. And the last one, the last test case, should be giving us no roots, right? And that's what we're getting. So right now, 2 of our test cases are passing. The other 2 are looking good because we're getting the 2 roots back, but we actually have to compute those. So I'm going to compute those roots. At this point, it's just really kind of just cranking out an equation. Remember, Python can do the square root for us in the math package. I got to import that. And that's the square root of the discriminant. And now the whole thing is divided by 2 times a. X2 is the same exact equation, but subtraction. And I'll return the tuple containing x1 and x2. All right, and so looking at the results back here, remember I said the automated tests would be a little bit difficult because I'd have to actually compare the floats themselves. Those won't be exactly equal, so if I was to try to do equality against those tuples, there'd be a little bit more involved. We could use the absolute value to compare and contrast the first and second tuple to see whether it's within 10,000th of the given expected results. But I'm going to stop short of that at this point and just go with what's being printed out. Okay, so this example, the main takeaway here is the ability to create functions that actually can return multiple things. It can return a tuple containing the results set. And that'll often come into aid you in your development of functions.